hit play or record. Yay. All right, 45, 45, 30, 60, 90. The key to these problems is, for me, when I'm teaching them, is to not put X's and Y's for the base example. So what I do is show you alpha and beta, okay? So all that is a Greek letter, right? Usually you'll see them being used for sides, and then in geometry and trig and stuff like that, and calc and pre-calc, and then what do we use for angles, right? Same thing, Greek letters, but usually theta, phi, right?
Theta, like
So like this is theta, right? Phi, alpha, beta, right? When you get to college, you'll learn all of these, right? Because frat, sorority, row, okay? So anyways, 45, 45, this is alpha, and the reason why I use alpha is because usually your problems ask for X, right? And then you're like, which X is he talking about? So that's why I use alpha and beta. They never ask for alpha and beta, and that's why I do that. So let's talk about the first thing first. Is 45, 45 means that it's an isosceles triangle, right? That means that two sides are equal, right? Because two angles are equal, right? Plus we have a 90-degree angle. If we do by the Pythagorean theorem, we would find that this would be alpha square root 2. This is a base formula that we can use every single time. And so anytime you see a 45, 45, and they give you a side, I know right away what that side is, right? What is it?
10.
10, right. So right away, I'm locked in at 10. That one was easy, right? And then you could do a squared plus b squared equals c squared. But it's not that hard, okay? What's fun about these formulas, right, is that you know it is always whatever this value is times the square root of 2, right? So, boom. So what is c?
10 square root 2.
That's it. 10 square root 2. Now, how would you solve that? I mean, you could go through this section. I teach my geometry students. I'll say, okay, if b is equal to 10, right? Then, and so this gets real complicated all of a sudden. You're like, why is it so hard? And alpha square root 2 is equal to c, right? Let b equal alpha, right? Once you have that, this is the definition of what? 45, 45. So the definition of 45, 45 tells me that alpha square root 2 is equal to the hypotenuse. That's what it tells me, right? So definition of 45, 45, okay? Next, I'm letting b equal alpha, right? So, substitution. Then I plug it in. If b is equal to 10, then alpha equals 10, right? Substitution, okay? Well, then it's 10 square root 2 equals c, substitution. I mean, we didn't even do any math really here. We just subbed it in. That's how easy it is. Two-column proof is kind of long, right? But the math itself is real simple, okay? So, and we can talk about these two-column proofs, because from what I understand, you were not taught two-column proofs last year in geometry?
2 years.
Or last 2 years ago, right? So I'm teaching geometry. My classes are learning two-column proofs from the get. So we can always talk about this, and you can look on my website and see two-column proofs all day long, okay? Now, this one's a little harder, okay? Because they're a little different, right? Because we have two different types of formulas, right? So, the first formula is, what? 2 beta is equal to x, right? What does beta equal? So what, first of all, that's definition of what?
30, 60, 90.
That's it. 30, 60, 90, right? So that's all that is. Once I know that that formula is, then I need to know, well, what's beta? 5, right? Yeah, so I know that I have to say beta is equal to 5, right? And that's just given. Or you could say substitution, but it's, either one's fine with me, right? Now, what do? And you sub it in. So 2 times 5 is equal to x, right? If x is equal to, and so that's what I always show my students. It's like I set them up so they're like right underneath each other, and I say this and this are linked. This equals this. They're the same thing. So if I know what beta is, I can figure it out. Does that make sense? So 10 equals x. Right? And that's just, so here's substitution. Oops, sorry, that's orange. Substitution, and then 10 is just simplifying, right? Okay. Then what? What's y? Y,
3.
right, is equal to, yes, beta times the square root of 3. So y equals beta square root 3. Definition of 30, 60, 90. Substitute it in. Y equals 5 square root 3. Substitution. Done. Can it really be that simple?
Yeah.
Yes. Can it get harder?
Yes.
Yes. Yeah. So, and we'll do harder ones also, right? So, what's the hardest one you think? What could be the hardest one you could come up with? And I'll show you. We'll do this not right now, but in a minute, but just so the film knows. The hardest one is when this square root side, right? This square root 3 side, sorry, this square root 3 side is a number, a whole number, right? Some kind of integer. Why an integer? Because it's always going to be positive, right? So some whole number, not an integer, actually it won't be negative. So a whole number, right, or natural number. What's a natural number? All the numbers 1, 2, infinity. Why is that the hardest one? Because then you have to actually solve for the square root of 3 and figure out, you have to pull out a square root of 3 out of it, right? Yeah, you just divide by a square root of 3 and then you'll have the square root of 3. It's not that bad. It's really not that hard. It's just that's the hardest it gets, is all I'm saying. You know? And once you get it, it's solid, right? Good times. All right, cool. So if